In problem number 5, we have one more example of using a two-way table and some given events. The problem says the outcomes of two variables are small, medium, large, and blue, green, respectively. An experiment is conducted in which the outcomes of each of the two variables are observed. The probabilities associated with each of the 6 possible outcome pairs are given in the accompanying two-way table. We're going to consider these events below. So you can see that the two-way table has some probabilities already included, but I'd like to start with filling in the total column and total row. So if we add up the probabilities of the event being blue, that would be 0.25 plus 0.06 plus 0.18, and that makes 0.049. If the event is green, then we're adding 0.04 plus 0.37 plus 0.1, and that total is 0.51. Now looking across the events, the event is small, we're adding 0.25 with 0.04 to get 0.29. If the event medium occurs, that means we're adding 0.06 to 0.37, and that's 0.43. And finally, if the event large occurs, we're adding 0.18 and 0.10, so that's 0.28. Now, no matter if we add the totals in the row or the totals for the column, we should end up with exactly 1 every time. Never less, never more than 1. 1 represents 100% probability, and we cannot have more than that. So now we'll take a look at parts A through H and answer these probability questions. Part A is talking about the probability of event A occurring. Event A means blue has occurred. So we're going to look at the two-way table, and I'll erase those arrows. For event blue to occur, that means 0.25, 0.06, and 0.18 need to be added, and we've already found 0.049. Event B is a little more complicated because it actually involves 2 different events at the same time. So we're looking at small or blue. So when we see the word or, what that actually means is the union of small with blue. So small in union with blue. So I'm going to circle all of the probabilities involved with small, and then I'm going to circle all the probabilities involved with blue. Do you notice that 0.25 has 2 different colored circles? That means that is the intersection of those events. So be sure you do not include that 0.25 twice when you're getting your total. So the probability of B can be displayed 2 different ways. I could simply add all of the numbers that I've circled. So that would be 0.25 plus 0.06 plus 0.18 plus 0.04, and my total is going to be 0.53. So another way to look at that is to use the additive rule. The additive rule would take us directly to the totals. So the event small, that probability was 0.29, added to the probability of being blue, that total is 0.49. But remember how we had 2 circles around one of these probabilities? So when you're using the additive rule, you add the totals for the 2 events, but then be sure to subtract any intersection. So I have to subtract 0.25. But our final answer is still 0.53. So this method is using the additive rule. Part C. The probability of event C means green and large. The word and implies intersection. So green intersecting large. So let's erase all of our circles. And we're looking for green. Here are the probabilities involving event green occurring. And the event large would be these two values. And do you see how 0.10 is included twice? So 0.10 is the intersection. This is our answer. So we have 0.10. Event D, the probability. Next, for part D, we're looking at the probability of event D. Event D says medium. So let's erase what we already have on our two-way table, and we're looking just for medium. Well, we've already found the sum. 0.06 added to 0.37 makes 0.43. Now part E is a little more involved. It says the probability of A complement. So what that means is the probability of event A not occurring. Probability of event A is blue. So we do not want blue. So the probability of not blue would leave us green. So we could go directly to our total there of 0.51. But there is another way to think of it, and that is using our rule of complements. So that would be 1 minus the probability of event A. So that means 1 minus 0.49, and that is also 0.51. So we get the same answer, it's just another way to think about it using our rule of complements. For part F, we're looking for the probability of event A in union with event B. So everything involved with event A in union with everything involved with event B. So let's erase our ring, and we'll find event A is blue. So those probabilities will be circled. In union with event B. Remember, event B was small in union with blue. Well, we've already circled blue, so we need to circle all the probabilities involved with small. So we had one more probability to circle. So again, we could simply add up these 4 probabilities. So you'll notice they're the same probabilities involved with problem B. So our total is going to be the same. 0.25 added to 0.06 added to 0.18 and added to 0.04 makes 0.53. Part G is looking for the probability of A intersecting C. So let's erase and start fresh. Probability of A means blue. So here are all the probabilities involved with the event blue. Event C, we're looking for the intersection of green and large. That's our 0.10. Do you notice how the rings that I drew are not overlapping? In other words, they're not intersecting at all. So we do not have an intersection of events A and C. So the total probability would be 0 because there is no intersection. And finally, for part H, we're going to be considering different pairs of events and deciding if those two events are mutually exclusive or not. So we need to know what mutually exclusive means. To be mutually exclusive, events cannot intersect. So let's look at the comparisons. So the first 2 events that we're considering are A and B. That means blue and the union of small and blue. So we've got blue to be small and blue. That also involves the 0.04. So do you see how there is an intersection at 0.25? So these are not mutually exclusive events. The next two events are A and C. So again, event A is blue. Here are the probabilities for blue. Event C was the intersection of green and large. That's the 0.10. Do you notice how the rings are not intersecting? So those are considered mutually exclusive events. Next we'll consider A and D. Again, A is blue, so I'll leave my circle around blue. D is medium. Medium involves these two probabilities, and so it looks like 0.06 is shared, so those are intersecting, not mutually exclusive. The next two events are B and C. So event B, small in union with B, so small in union with blue. And event C is the intersection of green and large, so that's our 0.10. We don't have any overlap, that means no intersection, so those are mutually exclusive events. Next we're considering B and D. So B, smaller blue, so small blue. And D says medium. So if I circle everything that's medium now, you notice how 0.06 has two different colored rings around it, so I counted that twice. That's an intersection, so not mutually exclusive. And let's see, our last set to consider are C and D. So starting over, C would be our intersection of green and large right here. And event D is medium. So medium 0.06, 0.37, no intersection there. So those are mutually exclusive events. So what's important to take from this exercise is the definition of mutually exclusive, and that is events that are not intersecting. Also, it's important to look carefully at the details of the events that are given to understand if, in fact, the word or means the union of the events, and the word and implies the intersection of events.